support vectors and we are considering margins, and every element in two classes is beyond the margins, then it is called as what? Hard margin.
Hard margin.
And if we allow some of the elements within the margin, Joyce will say,
Sir, are you sharing the screen?
yes, I'm sharing the screen.
കാണണില്ലല്ലോ.
ആർക്കും കാണുന്നില്ലേ?
കാണുന്നുണ്ട്.
വിസിബിൾ ആണ്.
കാണാം.
മിസ് ഒന്ന് ലോഗ് ഔട്ട് ചെയ്തൊന്ന് കയറി നോക്കോളൂ. Okay. If we allow some of the elements within the margin, then that problem is actually called as what? Soft margin.
Soft margin.
ഇതാണ് ഇതിന്റെ basic idea. And the mathematical formulation is there in that particular slide. ഞാൻ അത് പറഞ്ഞു കഴിഞ്ഞാൽ വെറുതെ ആവശ്യമില്ലാത്ത കോംപ്ലിക്കേഷനിലേക്ക് പോകുന്നത് കൊണ്ടാണ് ഐ ആം ജസ്റ്റ് സ്കിപ്പിംഗ് ദാറ്റ് പാർട്ട്. അതിന്റെ ആവശ്യമില്ല നമുക്ക് ടു അണ്ടർസ്റ്റാൻഡ് ദ കൺസെപ്റ്റ്. സോ എന്തെങ്കിലും നമുക്ക് ഡൗട്ട് ഉണ്ടെങ്കിൽ you can actually directly call it. Okay.
Sir, I cannot see this PDF pushed somehow. Is that?
I just pushed now. Can you just sync
Okay,
it now?
okay.
Yeah. Okay, fine. So everyone is clear about support vector machine and KNN. Sorry, KNN we have to discuss, right? So we can actually discuss about KNN. KNN is very simple algorithm, and this is there in this slide. Okay, almost every techniques are there properly explained, and the evaluation matrices are also there. I have updated the slide and uploaded it again. Okay, so hope these things are clear, right? Okay, now KNN. Okay, KNN is another machine learning algorithm. Okay, another machine learning algorithm which is used for classification. Okay, and the intuition is that K nearest neighbors, right? If it walks like a duck, then it is probably duck. That is, if one observation is very similar to some other observations, then that one observation also belongs to that group, right? So in KNN classification rule, what is happening is we assign to a test sample the majority class label if it's K nearest training samples. Okay, if it's K nearest training sample. So K usually chosen as odd and K equal to 1, the nearest neighbor rule. And usually the rule of thumb is we have to choose K as square root of n. What do you mean by square root of n? The square root of number of samples in the data. We usually choose like that. Okay. And how it works? See, the K nearest neighbor of a record X are the K data points in the training set with smallest distance to X, right? So if this is the new observation, the testing data, if K equal to 1, one nearest neighbor is, we are considering only one neighbor. If you are considering two neighbors, we choose two nearest neighbors. And if you are considering three, we will be considering three neighbors, nearest neighbors. And what is the criteria for predicting a particular class? See, understanding this notation is somehow important. Okay. So if we have some observations, so this is our observation, and I have some observations over here, the nearest one. Okay, and some observations over here, and some observations over here. Okay, So f dash of q, a query, okay, f dash of q is equal to argmax of sigma, okay, argmax of sigma equal to 1 to k, v comma f of xi, okay, v comma f of xi. So what is this v comma f of xi? How can we understand this? Okay, so this v is nothing but what? V is nothing but this plus see, v is nothing but this plus and plus and minus. Okay. So we have to find a v, okay, we have to find a v such that delta of v comma f of x, f of I. So delta of, what is this delta function? What is this delta function? Delta of xx is 1, delta of xy is 0. If both the arguments are same, it will be 1. If both the arguments are different, it will be 0, right? So we have to choose a v, then this xi, okay, xi is nothing but xi is an element of capital X, which is equal to the neighbors, okay? Xi എന്താണ്? The neighbors. So plus, 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 and we have okay. Now, argmax of this particular quantity is what? Maximum. Okay. So we have two possibilities, right? We have two possibilities. As we are having two classes, we have two possibilities, right? So we have to choose from, we have to choose a V, okay? We have to choose a V. So if V is equal to, V can be either what? Plus or minus, right? If there are more possibilities, you can do like this. So what we have to do is, we have to check sigma delta of okay, delta of f of xi. Here sigma delta of f of xi, right? And in one case, the delta is what? Minus, and in the other case, delta is plus. And f of xi is the label of this particular observation. Okay. So we have to choose each xi. Okay, we have to choose each xi and its corresponding label. So what will be this sum? what will be the sum? This will be equal to delta of plus 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 delta of plus minus plus delta of plus minus plus delta of plus minus. Okay, like, and this will be delta of minus plus plus 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 delta of minus minus plus delta of minus minus plus delta of minus minus. Okay. So what is the sum of this?
4,
4. And what is the sum of this?
3.
3. Right? So which one is actually giving? Okay, which one is actually giving? Which B is actually giving
Next
more value? Is it plus or minus?
plus.
Plus. So the query of, right? The query of, the label of the query is what? Plus. Is it clear? Is it fine?
Sir, actually, you're trying to classify that green dot into class plus or class minus,
Minus.
right?
Yeah. So
And
we have to
you are-
count it.
we have to count the plus and minus and find this delta.
Yes. We are
Assuming
considering
it is plus and
we are
assuming it is minus.
minus. We are considering this much. Okay, we are considering this much neighbors. That is 7 neighbors here. So k equal to 7.
Okay.
And to mathematically formulate it,
We
simply we
have
need to.
so 5 plus 3, 8 is there, right?
No, 1, 2, 3, 4. Yeah, actually, but here I have taken only 4. You can actually ignore this. Okay.
Okay, then it is fine. I was not able to get that
Yeah.
number correctly. Okay, so
4
right
and
now we have 4 plus and 3 minus.
minus. That is
Okay,
X.
so okay.
The neighbors are the X.
Okay.
Now we are actually matching each distinct class with the neighbors class.
Okay.
Plus with the neighbors and minus with the neighbors.
Minus with the neighbors and trying to find which one gives the maximum value.
Maximum value. That's it.
Okay.
Okay. That is what we are calling as what? K nearest neighbor. Is that clear for everyone?
Why you are putting it as f of xi? It's actually class, right?
Yeah. Because each observation is xi and f of xi is the class of that observation. Like if plus 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 plus, okay, and minus minus minus. Each of this observation is xi, x1, x2, x3, x4, x5, x6, x7, x8, and x9, right? And I have to check with plus and not x1. It should be the label of x1, right? Then only it is plus and plus. F is actually mapping. F is actually mapping each observation into its corresponding class. മനസ്സിലായോ മിസ്സിന്?
സർ നേരത്തെ സർക്കിൾ വരച്ചിട്ടേ
ആ.
ആ സർക്കിളിന്റെ ഉള്ളില് 4 + 3 - ഇട്ടില്ലേ?
ആ.
പിന്നെ സർക്കിളിന്റെ പുറത്ത് അതും സാമ്പിൾസ് അല്ലേ?
അതെല്ലാം
അങ്ങനെ?
സാമ്പിൾസ് ആണ്. നമ്മൾ എടുക്കുന്നത് നമുക്ക് പ്രെഡിക്റ്റ് ചെയ്യേണ്ട സാമ്പിളിന്റെ അകത്തുള്ള k നെയ്ബേഴ്സ് മാത്രമാണ്.
ആ കെ ഉള്ളതുകൊണ്ടാണ് അങ്ങനെ
k = 7 ആയതുകൊണ്ടാണ് നമ്മൾ അവിടെ 7 എടുത്തത്. ഓക്കെ. Okay. So here there is a variation of distance weighted k nearest neighbor. Okay. Instead of taking the simple matching of the classes, we will normalize that matching with the inverse of the distance between that point and the query. Right? Is it clear? That is what we are calling as distance weighted k nearest neighbor. Okay, like suppose we have k equal to 3. Suppose we have k equal to 3. So I have 2 observations here and 1 observation. Blue. Okay. And usually what we will do, we will consider
The point
number of-
is
yeah, that is if this is observation 1, this is observation 1, 2 and 3, we will check like for minus, the sum will be 1 plus 1 plus 0, right? And for plus, it will be like 0 plus 0 plus 1. So what is the value? This 2 here and this is
and one.
1. So we will map this observation into minus class, right?
Yes.
So in distance weighted k nearest neighbor, what is happening is, see, along with the nearness, we will calculate the distance too. Okay. So this distance is 2, this is 4, this is 3. Okay. Instead of 1, 1, 0, what we will do? For minus, we calculate 1 by 2 square plus 1 by 4 square plus 0 by 3 square. And for plus, it will be like 0 by 2 square plus 0 by 4 square plus 1 by 3 square. So what is the total value? 1 by 4 plus 1 by 16 is this value, right? And this is 1 by 9. And what about this? 5 by 16. And this is 1 by 1, which is more greater, 5 by 16. What is the value of 5 by 16? It will be like 1 point something. Sorry, 1 point, not 1 point. What is 5 by 16? Can anyone calculate 5 by 16?
0.375.
0.375.
375.
And this is 1 by 9 is particularly
0.9.
1 by 9.
0.1 something vary.
0.11. So which is more value, which is having more value? Which is have more value?
0.375.
0.37.
0.37. So why we are actually taking this is that, see, in some cases, okay, in some cases, the data will be distributed like this. 1 plus is here and 2 plus is here. and we are considering 2 points over here. And our point will be, the new point will be somewhere very near to this. So if you consider 3 neighbors near to this, which all neighbors will come in play? These 3 will be the neighbors, right? Is it clear?
What means where you are drawing this curve? I mean, right, if you are drawing towards right side, it may include the other
Like,
point also, right?
no, like, see, this distance is 2, okay? This is 5. This is also 5. Say this is 5.5 and this is 5.5. Now the 3 neighbors are,
The one
like,
which is very close to that point.
the point is like this, right?
Okay.
Now, what is the distance? What is the criteria for B? By simply counting, which one is the, which class we are mapping?
It will be minus.
Minus, right? But from the visual itself, we can say that this belongs to this plus, right?
Yes, yes.
So how can we tackle this? If we simply use this simple majority vote, this won't work, right? But if you consider this weighted one, how it works, can you just see this? It will be like, see, for minus, the sum will be 1 by square, 5 square plus 1 by 5 square plus 0 by 2 square, right? And for plus, what is it? For plus,
1 by
0 by
0 by 5
5
square
square,
plus
0
0
by
by 5 square
plus 1 by
plus 1 by 2
2
square.
square. So what it will be? Just 2 by 25 for the first one, right?
Yes.
2 by 25 will be the first one. And what is this blue? It is 1 by 4.
1 by 4.
So which is more big?
1
1
by
by 4 is 1 by 4 is 0.25 and
The
2 by
other one is 0.08.
0.08. See, now if you consider this weighted value, we can map it as plus, right?
Yes,
One
yes.
doubt.
Yeah.
So what about if this plus is a outlier?
If this plus is at, but we can actually
Is
see
it
a
something
margin. The outlier is
okay.
something like if it appears like this. In the region of red, if blue is appear, we can say it is what? An outlier.
No, sir, my question is basically, let me ask more. So should we use K to higher value, like not to 3 or something like 9, 10, 11, even odd number mostly? But
Yeah, we can do
does
that.
it,
That is the
so
rule.
that will help us to remove this outlier. Like if it might be like all plus are near this other plus only, and
Yeah.
this one plus is only here. And since we are considering 3 and this is the causing outlier, right? So
That
something.
maybe like while observing, by collecting the data, by maybe some chance of we are missing some observation from here too, right?
Yes, okay.
Yeah.
Okay.
So here we have 5 data. The key is K can be equivalent to root of 5, right?
Okay. K can be root of 5. Okay.
So something 2 point something. That is, we have to take 3 neighbors.
3 neighbors. Okay.
Yeah.
And can we use even number as well? But it might,
If even number is used, it will be a tie.
it will get tie, right? So
Yeah.
how then can we, like, because root of, let's say you have a 16 points, data points.
You
Then
can take
4
the
is
next, if it is even,
next
you can
plus
take the
1,
next
right?
value. Yeah.
Okay, sure. Okay, sir. Thank you.
Yeah. So how KNN is clear for you, right? So KNN is the basic algorithm, and the weighted KNN, we can consider the distance towards each point also. Okay. So issues in KNN, choice of K is a difficulty. Distance matrix, how to calculate the distance between 2 points, computational complexity, size of training data, and dimension of data. These are the major issues we are facing. And if K is too small, we are choosing K is too small, it becomes sensitive to noise, and K is too large, the neighborhood include other classes too, right? And what is the thumb rule? So for being safe, K can be chosen as approximately equal to root 10. And what is this root 10?
Training points only, right,
Yeah,
sir?
N is the
Not complete data.
number of training points.
Training point.
Yeah, and this algorithm is actually called as lazy learner because this is not calculating any kind of models here, right? The data itself is kept as model. So this is called as a lazy learner. Is that fine?
Yes, sir.
For everyone, can all of you
Sir,
respond?
how the dimensionality of data is a problem in KNN? Like, can some
Because it will increase the computational complexity. If you go for finding the distance between these 2 points, it will be more
okay, so
complex, right?
basically more n, and so because more feature, more dimensions, then more computation to
Yes,
calculate the
computer.
distance basically.
Yes, yes.
Okay, so it's our own interrelated. Okay.
Yeah. And the choice of functions we can use for this dimensionality is that, see, we can use, we usually use the Euclidean distance, that is root of sigma xi minus yi whole square, right? Similar to that, there are other measures, Manhattan distance. We are simply taking the absolute value, okay? Then we can take Canberra distance, mod x minus y by x plus y. And Minkowski distance is actually a generalization of this Euclidean and Manhattan. See, since we are taking square, we are taking square root, right? And here we are taking only the first power. We are not taking square root. So here we are taking the power r, then we will be taking the rth root of it. That is the generalization of Euclidean distance and Manhattan distance. Then Chebyshev distance can be considered, that is maximum of xi minus yi. Then quadratic distance can be calculated. Manhattan distance can be calculated. Correlation, chi-square, Kendall. These are all different choices of what? Distance matrices. So if you're working with KNN algorithm, while writing papers and all, we can actually consider this particular thing, distance metric as a hyperparameter. Then we evaluate the performance of KNN algorithm with all these distance measures and try to report it on the paper. Okay. So this will be a good study because for a particular problem, which distance is actually giving better results is actually a good finding. So that's about what? Bayes theorem. Okay. Sorry, the KNN algorithm. Now we are moving into Bayes theorem. So pay attention here, otherwise you will get confused with the concept. Okay. So we know Bayes theorem. We know Bayes theorem, right? Do I need to recollect or re-explain it about Bayes theorem?
Sir, yes, please, a quick.
Yeah. What is the probability of A given B? It can be calculated as probability of A given B is equal to what?
Probability of B given A divided by
Probability of B given A
A
into
divided into
probability of
A
A.
divided by
A.
A
probability
divided by
by probability of
probability of
B.
B. Okay, that is sometime it is difficult to observe the probability of A given B, but it is easy to observe what? B
B
given A.
given A.
And this is called as posterior, right? And this is likelihood, and this is evidence. Okay. I think I made a confusion. That is not posterior. Likelihood, sorry.
B
Prior,
given A
yeah.
is likelihood.
Yeah, this is likelihood, and this is prior. Okay. So, this is likelihood and this is prior. So, from this, we have to calculate the posterior probability of a particular event, right? So, we explain that thing with a particular example. See, corona is there and fever is there, right? So, there are 50 people in the hospital, okay? And among that 50 people, 8 of them are having corona symptoms, okay? So, they have taken test. So, the rest of the 42 is there. So, by taking the test, we see that, okay, we see that 5 of them are having corona and 3 of them are simply symptomatic. And after testing this, we can also find whether these people are having what? Fever. Is it clear? This data is easy to observe, right? But the other 42, in this 42, maybe or in this 50, maybe 46 people are having fever. Okay, but they don't have the symptom of what? Corona. So for simply because of fever, can I say you just go and take a test for corona? Is it possible? Will they allow that?
No.
No. So that is what I said. Probability of fever given corona is easy to calculate, right? But probability of corona given fever is what? Difficult to calculate. So that thing, the probability of corona given fever need to be calculated as posterior probability. And there we know the likelihood of it. Probability of fever given corona. We know that. We know the probability of what? Corona. And we know the probability of what? Fever. So how can I calculate corona, the probability of fever given corona? How many of them are actually having corona? 1, 2, 3, 4, 5. And among this 5, how many of them are actually having fever? 1, 2, 3, 4. Is that clear?
Yes.
So it is 4 by 5 into what is the probability of corona among 8 people? 5 of them are having corona, right? And what is the probability of fever? 1, 2, 3, 4, 5, 6, 7, 8. Among 8, how many corona people? Sorry, how many fever people?
Fever is 5.
5.
5 by 8. So what is that? 4 by 8 plus 5 by 8. That is 8 cancelled. 4 by 5, which is equal to 0.8. That is, if someone is having corona, there is 80% chance. So, sorry, someone is having fever. There is 80% chance for having corona from this data. Is that clear? Are you
Yes,
getting
sir.
it?
Yes, sir. Yes, sir.
Okay. Everyone is clear, right? So, our classification problem. What is our classification problem? What is the classification problem? We have to check. We have an x. X is what? X1, X2, X3, etc. up to Xn, right? The n values for features, right? What is the probability that these features are pointing to a particular class? So what is the probability that for a given class, X belongs to that class? So X is already there, right? X is already there. Then what is the probability that C is actually the mapping of X? Is that clear? So with Bayes' theorem, how can I define this? With Bayes' theorem, how can I define this?
So probability of X given C is there
Probability of X given C
into
into probability of C
C divided by
by
probability of
Probability of X.
probability of X, right? So the C can be different classes, right?
yes.
C can be different classes. C can say there are 3 classes, okay? So we have to calculate what is the probability of C being C1 given X, right? What is the probability of C given C2 given X? And what is the probability of C given
C3
C3 given
given
X, right? So this is equal to probability of X given C, probability of C divided by C1, right? C1, probability of X, right? Probability of X given Z2, probability of C2 given probability of X. Probability of X given C3, probability of C3 divided by probability of X, right? So, one which is having maximum probability. If this value is having maximum probability, then we will choose X belongs to C1. Is that clear? If this probability is maximum, then we will choose C2 as the mapping of X. If this is maximum, we will choose C3 as the class.
X.
Okay. So how can we choose this? In a mathematical form, how can I write this? C star is the class of X if probability of C star given X, right, is greater than, right, probability of C star given X is greater than probability of C given X for all C not equal to C star. Is it clear? C star അല്ലാത്ത മറ്റെല്ലാ ക്ലാസ്സുകളുടെയും പ്രോബബിലിറ്റിയേക്കാൾ കൂടുതലാണ് ആരുടെ പ്രോബബിലിറ്റി? സി സ്റ്റാറിന്റെ പ്രോബബിലിറ്റി ഗിവൺ എക്സ് എങ്കിൽ we can say C star is the mapping of what? X. Is that clear?
Yes, sir. Actually, but for the example of that grouping that the leaves based on petal size, this
Yeah.
X will be that size distribution, like for one particular group, we are
Yeah.
having a range of values, right?
Yeah.
In case of corona, it is easy. Corona or Nipah, we can
Yes.
take that class.
We can actually
But
extend that idea.
Okay. For the same feature, when you have different values,
Yeah.
this is for different feature, right? Like
Yes.
for the one feature is allotted to one class.
Yes.
For the same feature, when you have different values and you have to classify,
Yeah.
then you are taking one
Having
range
different
as
values,
X,
right?
right?
Yeah.
One range as X, and then that range is grouped or connected to or mapped to this particular class.
Yes, exactly.
Okay, thank you.
So here, to check the maximum of these probability, you can see that, see, this part is common for all, right? P of X is common for all, right? Is it clear? Is it clear, right?
Yes.
So we can say that probability of C equal to C star given X can be compared approximately equal to probability of X given C star
Sister.
into probability of C
Mhm.
star, right?
Yes.
Right? And the X itself is not a single random variable. The X is actually what? X1, X2, etc. up to Xn given C star and probability of C star, right? Right? And we always assume, that is why it is called as name. We always assume these features are independent. What is that? These features are independent. Then this particular thing, since these are independent, okay, this particular probability is equal to probability of x1
X
given C
sister
star
into
into probability of
X2.
x2 given C star into probability of x3 given C star, etc. up to probability of xn given C star, right? Into probability of what? C star. And this could be represented as, so probability of C star given X can be calculated as product of I equal to 1 to n probability of xi given C star into what? Probability of C star, right? So to calculate this, what we have to calculate? We need to calculate these probabilities. One particular feature is a value, and what is the value for? What is the probability that C star given that particular value? then C star given next value, C star given next value. These probabilities need to be calculated, and the probability of the class also need to be calculated. Then with that given data, we can calculate the final probability, right? So I'm illustrating that example with the slide, okay? Yeah. So now you can actually understand, right? The score of C is equal to probability of X given C into P of C, right? And which is a class we are considering. The class C star is equal to the class which gives this probability maximum, right? Class which gives the probability maximum, right? And how can I understand that? See, we have to calculate probability of C given X, okay? C given X. But it is difficult to calculate, we have to calculate probability of x1, x2, etc. up to xn into C, right? But it is difficult to calculate that. So we have to calculate this independently. That is probability of x1 given C, probability of x2 given C, and probability of xn given C, right? So ultimately, what we have to do is, for all targets, estimate the probability of each target from the data. Estimate the each target from the data, right? Then find the probability of each feature value for a class. Probability of each feature value for a class. So this should be what calculated before. So we will get a conditional probability table for here, right? And if a new instance comes, okay, a new instance comes, what we have to do? We have to calculate these probabilities, okay? We have to calculate these probabilities, and one which is having the maximum probability can be assigned as the target class. So, see, this is our data. See, here we have some weather conditions, outlook, how the day outlooks, the temperature, the humidity, and the wind, right? Outlook, temperature, humidity, and wind. So based on the different possibilities of outlook, temperature, humidity, and wind, I will decide on whether I will play football or not, whether I play tennis or not. Is that clear? Clear ആണോ ഇതുവരെ പറഞ്ഞത്? നമ്മൾക്ക് ഔട്ട്ലുക്ക് ഉണ്ട്, ടെമ്പറേച്ചർ ഉണ്ട്, ഹ്യൂമിഡിറ്റി ഉണ്ട്, വിൻഡ് ഉണ്ട്. And based on these four features, I am deciding whether I will play tennis or not. Is it clear? So how many observations are there?
14.
14 observations. So among this 14, I need to calculate the probability of play equal to S, probability of play equal to no. Okay,
So this is probability of C star basically, right,
yes,
sir?
probability of C star.
Okay.
So probability of S is equal to 9 by 14. Probability of play equal to no, 5 by 14, right?
Yes.
Now, for outlook, we have to calculate probability of sunny given no, overcast given no, rain given no. Similarly, sunny given S, overcast given S, and rain given S. Are you getting it? For the outlook, we have three possible features, three possible values, and for each of that value, the target can be either yes or no, right? So we have to calculate the conditional probability of C. We have to calculate the conditional probability of C, sunny given S. Okay. So among 9S, there are 9S, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. From this 9S, the outlook feature, how many of them are sunny? Sunny, sunny, right? So it is 2 by 9. Are you getting that? What is calculated here?
Yes, sir. Probability of
Yes, sir.
Yeah,
C given X.
yes. So
Sunny,
സണ്ണി എസ് ആകുമ്പോൾ ഞാൻ കളിക്കുമെന്ന് തീരുമാനിക്കുമ്പോൾ എത്ര ദിവസങ്ങൾ എന്തായിരുന്നു?
nine
സണ്ണി
out of
ആയിരുന്നു.
9 is 2 days
ആ സണ്ണി.
were sunny.
Out of 9 is 4 days were overcast. Out of 9 is 3 days are rainy. Similar to that, no, ഞാൻ കളിക്കുന്നില്ല എന്ന് തീരുമാനിക്കുമ്പോഴും what is the conditional probability was sunny, overcast and rain? Okay അല്ലേ? ഔട്ട്ലുക്കിന്റെ ടേബിൾ ഓക്കെ അല്ലേ? Right? And
Yes.
similar to that, the second feature. What is the second feature? Temperature. That also having 3 possibilities, right? Hot, mild and cool. Hot ആയിരിക്കുമ്പോൾ ഞാൻ എത്ര ദിവസം കളിച്ചു, മൈൽഡ് ആയിരിക്കുമ്പോൾ ഞാൻ എത്ര ദിവസം കളിച്ചു, അല്ലെങ്കിൽ കളിച്ചപ്പോൾ എത്ര ദിവസം ഹോൾഡ് ആയിരുന്നു, കളിച്ചപ്പോൾ എത്ര ദിവസം മൈൽഡ് ആയിരുന്നു, കളിച്ചപ്പോൾ എത്ര ദിവസം കൂൾ ആയിരുന്നു. സിമിലർലി കളിച്ചില്ലാത്തപ്പോൾ എത്ര ദിവസം ഹോട്ട് ആയിരുന്നു, കളിച്ചില്ലാത്തപ്പോൾ എത്ര ദിവസം മൈൽഡ് ആയിരുന്നു, കളിച്ചില്ലാത്തപ്പോൾ എത്ര ദിവസം കൂൾ ആയിരുന്നു. റൈറ്റ്? സോ can anybody tell me what is this probability? ഇതിനെങ്ങനെയാണ് റൊട്ടേറ്റ് ചെയ്യുക? ആരെങ്കിലും ഒരാൾ പറയാമോ? What is this probability? How can I notate this? Probability of
No.
Normal
Probability
given
of
no.
play equal to no.
yeah, probability of normal given
Play equal to no.
No.
no. Okay അല്ലേ? അപ്പോൾ ഓരോന്നും you are able to connect, right? What is this probability? Right? Okay. Finally, what will happen? This is our model. So in naive base, this is our model, right? From the data, this is the thing we are actually calculating. So along with these tables, okay? Along with these tables, these two probabilities, the class probabilities are our model, right? Now, a new day comes, that is sunny, cool, high and strong. Sunny, cool, high and strong, right? So I need to predict whether I will play or not. So we have to calculate what here? We have to calculate probability of S, play equal to S given sunny, cool, high and strong. This is we have to calculate. And with the help of Bayes theorem, I can calculate this probability as probability of sunny given S
yes.
into probability of cool given S
Given yes.
into probability of high given
given yes.
S into probability of strong given
yes.
into probability of S.
X.
Right. So these sunny given S, cool given S, high given S, strong given S is 2 by 9, 3 by 9, 3 by 9, 3 by 9, and play S is what? 9 by 14. So on multiplying all these things, we are getting probability of X given X star is what? 0.0053. And similarly for no, we will calculate the same thing. Then what is the output we are getting? 0.0206. So with this conditions, will we play or not?
No.
No. Right? The probability of S given S dash is less than probability of no given S dash. So this time we are not going to play. Is it clear for you? Everyone?
Yes.
Yes. Yes, sir.
Okay. So neighbors ഇത്രയേ ഉള്ളൂ. എളുപ്പമല്ലേ?
Sir, one.
Yeah.
Since here we are doing this, all the probability,
Categorical values, right?
yes,
Yeah.
but how about this?
Yeah, that is what I'm
Okay,
going to discuss.
okay,
Okay.
okay.
I was actually supposed to give this as an assignment. Okay, how can you just think about any of the idea
Sir,
that
we used to do binning in such kind of thing, right? We put,
exactly that
so
is what we are actually
that
doing.
was what, okay, that
Yeah.
is what, okay.
See, so what we usually do is we will do binning. So what the assignment question you can note it down. What if the features are continuous while doing naive-Bayes classification? So there is something you can look into. See what kind of probability random variables we are actually considering here for each feature. I could say these are all different random variables, right? So what kind of random variables are outlook, temperature, humidity, and wind? Nobody's answering. What kind of
So categorical values.
categorical values are there about random variable? What type of, there are two type of random variables.
Discrete.
Discrete random variables, right? So
Yeah.
our discrete random variables, we have a probability distribution table here, right? Then if these are numerical values, what kind of random variables are that?
So it's continuous, but
Continuous.
Continuous random variables. Then how we are representing the probability distribution of a continuous random variable?
Normal distribution.
Using a probability distribution function, right? Using a
Yes.
probability
Yes.
distribution function. And if you have a probability distribution function, we have an assumption at the very beginning that every feature must be what?
independent.
Following
Following normal distribution.
Normal
normal
distribution.
distribution. So if you are given with a set of feature values, is it possible to find the mean and standard deviation from that? Mean and standard deviation from that?
Yes.
Yes. Then is it possible to find probability value for any of the observation with that normal distribution function?
Yes.
Yes, that is the solution. Are you getting it? So instead of taking the probability table, we fit this data into a normal distribution, and that normal distribution equation is actually used for calculating what? The conditional probabilities. Is that clear? Gaurav Manslayo. Gaurav, are you understanding that?
Yes, sir. Basically, first we are going with probability distribution and function, and
Yeah.
there we are calculating the probability of that distribution,
Yes, exactly.
particular parameter.
Because every field can be approximated into a normal distribution with a particular mean and standard deviation, right?
Yes.
Then for a given value, we can actually find out what probability distribution, probability of that particular thing. Okay.
Yes.
Yes. Hope it is clear, right? Can we go for the next algorithm? This is the last one we are actually going to discuss. Okay. So this algorithm is actually called as decision tree. Okay. So decision tree is actually representing another kind of classification algorithm based on theories from information theory. So a tree of if-then rules that partition the feature space into axis, parallel rectangles, each labeled with a class. Okay. So we have a decision tree like this. First, we will find out among the features which feature is more important. And based on the different values of that particular feature, we will grow the tree, right? So for the previous data itself, if outlook is overcast, definitely I will play. But if outlook is sunny, then what I have to do is I need to look for next important feature. And the next important feature is what? Humidity, if you consider outlook as sunny, right? And the humidity is high, then we don't play. If humidity is normal, then we will play. And if the outlook is rain, and then we will look for what? Wind. And the wind is strong, we won't play. Otherwise, the wind is weak, we will play. Right? So what is the question that comes in your mind? How can I find the important feature, right? Are you getting that? How can I find the important feature? For that, we have different mechanism. Okay. For that, we have different mechanism. So usually we will go with a particular thing called entropy gain. What is that? Entropy gain. So entropy is a measure and information gain is another measure, and one which is having high information gain is actually chosen as what? One which is having high information gain is actually chosen as what?
Important feature.
Most important
feature. Okay. So here, so you can see that, see, A1, by taking A1, there are 29 positive observations and 35 negative observations. Okay. So by taking A1 as a best split, what it will produce? We will get 25, 21 positive classes on the left and 5 negative classes on the left, then 8 positive classes on the right and 30 positive classes on the negative classes on the right. Right?
സർ ഈ ഡാറ്റ എന്താണ് ഈ പറഞ്ഞുകൊണ്ടിരിക്കുന്നത്?
ഇതൊരു ജനറൽ ആയിട്ടുള്ള ഒബ്സർവേഷൻ ആണ്. സോ ഹിയർ നമുക്ക് ഇങ്ങനെയുള്ള A1 എന്ന് പറയുന്ന ഒരു ഫീച്ചർ, A2 എന്ന് പറയുന്ന ഒരു ഫീച്ചർ ടാർഗറ്റ്. ഓക്കെ. അപ്പോൾ A1-ന് പോസിബിളി ട്രൂവും ഫോൾസും ഉണ്ട്, A2-നും എന്തുണ്ട്? പോസിബിളി ട്രൂവും ഫോൾസും ഉണ്ട്. റൈറ്റ്? ആൻഡ് A1 വെച്ചിട്ട് സ്പ്ലിറ്റ് ചെയ്യുമ്പോൾ ഈ ക്ലാസ്സസ് പോസിറ്റീവ് ക്ലാസ്സസ് ഉണ്ട്, സം നെഗറ്റീവ് ക്ലാസ്സസും ഉണ്ട്. സോ A1-ലെ ട്രൂ എല്ലാം കൂടി എടുത്താൽ A1 ട്രൂ ആവുന്ന ഒബ്സർവേഷൻ എല്ലാം കൂടി എടുത്താൽ
We
A1
have
ട്രൂ
21,
ആവുന്ന
21.
21 പോസിറ്റീവ് ക്ലാസ്സസ് ആൻഡ് 5 നെഗറ്റീവ് ക്ലാസ്സസ്. A2 A1 ഫോൾസ് ആകുന്ന എല്ലാം എടുത്താൽ 8 പോസിറ്റീവ് ക്ലാസ്സസ് ആൻഡ്
30 negative classes.
30 നെഗറ്റീവ് ക്ലാസ്സസ്. ബട്ട് A2 നമ്മൾ അതേ ഫീച്ചേഴ്സ് ആക്കി എടുത്താൽ A2 ആണ് നമ്മൾ സ്പ്ലിറ്റ് ചെയ്യുന്നത്. A2 ട്രൂ ആവുന്ന വെച്ചിട്ടാണ് സ്പ്ലിറ്റ് ചെയ്യുന്നതെങ്കിൽ ഇറ്റ് ബിക്കം 18 പോസിറ്റീവ് ക്ലാസ്സസ് ആൻഡ് 33 നെഗറ്റീവ് ക്ലാസ്സസ് ആൻഡ് 11 പോസിറ്റീവ് ക്ലാസ്സസ് ആൻഡ് 2 നെഗറ്റീവ് ക്ലാസ്സസ്. ഇത് നോക്കുമ്പോൾ എവിടെയാണ് നിങ്ങൾക്ക് കൂടുതൽ അൺസർട്ടനിറ്റി വരിക? Which one is having more uncertainty? Which one is having more uncertainty?
Sir, can you
Mm.
explain what do you mean by uncertainty here? sir?
Yeah, uncertainty is the confusion in the classes. See, if you take A1 as a splitting feature, by taking its true value, majority of the observations is actually belongs to positive, and some of the observation is what belongs to negative. And by taking false, majority of the elements belongs to negative class, and some of the observations only belongs to positive class. That is, this true almost indicate that is positive class, right? And the false is almost indicating what this is negative classes. So A1 equal to true means the probability of positive class is high, right? And A2 is equal to 2 is probability of negative classes high. But can we say the same thing here? If A2 equal to true, 18 of them are positive and 33 of them are what?
Negative.
Negative. So is it giving a clear idea?
No. In negative, false, it is giving clear idea, but for true,
But
it is
for
not
true, it is not giving proper
Clear.
idea, right?
Yes.
So how can I say, how can I choose the attribute that I can rely upon?
Okay, so
That is
more
A1, right? More
clear
more
idea.
yeah, more uncertainty is, sorry, less uncertainty give more information gain, right?
Yeah.
And what
Okay,
is the
more
measure for uncertainty? Entropy.
probability. Okay.
The uncertainty can be calculated using what? Entropy, right? So that is the core idea of what? Decision tree. We will consider the entropy as a measure. What is that? The entropy as a measure. So entropy is 0 means the set is pure, and entropy is 1 means the class is equally mixed, right? Equally mixed. So what we are doing is dominant class low entropy and equiprobable it is high entropy, right? So what we usually do is the gain of a particular class considering a particular attribute. Okay, we have a target, right? Data set, and we are considering a particular attribute. So for that, what we have to do is we will consider the entropy of S, okay? The entropy of S minus the entropies of different values of A. The entropies of different values of A. So the subset which is having V as a value divided by total number of elements in the subset into entropy of what? That particular subset. And this is called as information gain. What is that? Information gain. So the entropy of the subset minus entropy of each value in the subset for a particular feature added together and subtracted from the entropy of what? The class, then you will get an information gain of that particular attribute. So we can see this. See, in the root node, there are 9 positive classes and 5 negative classes. So what is the entropy of that particular target? Probability of positive, the entropy of positive plus entropy of negative added together and consider the minus. See, entropy of each class added together, the probability and log p of each class added together and put a minus. So what is that? 9 by 14 log 9 by 14 plus 5 by 14 log 5 by 14 added together and put a minus, then 0.94 is the what? Entropy of the target, right? Now the wind can be weak or strong. If you consider the weak subset, within that weak subset, we have what? 6 positives and 2 negatives. Weak as strong, 3 positives and 3 negatives. And we know here the entropy is 0.81. That is 6 by 8 log 6 by 8. How this is calculated? How this is calculated? 6 by 8 log 6 by 8 plus 2 by 8 log 2 by 8. Then consider the negative. That is what we are getting as 0.811. And here it is what? 3 by 6 log 3 by 6 plus 3 by 6 log 3 by 6 minus 3 by 6 is 1 by 2, right? 1 by 2 log 1 by 2 plus 1 by 2 log 1 by 2. That is log 1 by 2 to the base 2 എന്ന് പറയുമ്പോൾ എന്ത് തന്നെ വരും? This 1 തന്നെ വരും, right? So we found the entropy of weak and strong. After that, what we will calculate? Among this, we have to calculate.
Calculate for all the features, no?
Yes, all the features.
Then from that, which one is maximum?
Yeah, we
the-
will be calculating the information gain of outlook, humidity, wind and temperature. Then after finding this, you get the maximum information gain as 0.265. So we will split what? Based on outlook. Is that clear?
ഇൻഫർമേഷൻ ഗെയിൻ്റെ കാൽക്കുലേഷൻ ഒന്നുകൂടെ പറയാമോ? 0.94 is the entropy of the
Yes, given wind.
അല്ലല്ലോ, ടോട്ടൽ ഇതിനകത്തല്ലേ, റൂട്ട് നോഡിലെ അല്ലേ 0.94?
0.94 നമ്മൾ ആദ്യം എടുത്തത്. അത് വീക്ക് ആവുമ്പോൾ അതിന് 2 പോസിബിലിറ്റി ഉണ്ട്. വിൻഡ് വീക്ക് ആവാം, സ്ട്രോങ് ആവാം. ഓക്കെ, അതിന്റെ എൻട്രോപ്പി സെപ്പറേറ്റ് കണ്ടുപിടിച്ചു. ഇനി ആ വിൻഡ് എന്നുള്ള ഫീച്ചറിന്റെ എൻട്രോപ്പി, വിൻഡ് എന്നുള്ള ഫീച്ചറിന്റെ
8/14, how we were able to get that 8/14?
ഏത് 8/14?
8 is
ഇത്
that is
രണ്ടും
we
കൂടെ
have
ചേരുമ്പോ 8.
8. Okay.
Number of elements in that subset
okay.
divided by total number of elements.
Number of weak events is 8.
Yeah.
Out of 14.
14 into weak in the entropy.
Okay, 0.811.
And number of strong divided by 14. Strong in
Okay.
entropy. അപ്പോൾ നമുക്ക് എന്ത് കിട്ടി?
0.048.
0.04,
Yeah.
0.0488. Similarly, we will calculate it for outlook, humidity and temperature. അപ്പൊ ആദ്യം നമ്മൾ എന്ത് കണ്ടുപിടിക്കും? ഈ എച്ച് ഓഫ് എസ് അവിടെ തന്നെ. ഔട്ട്ലുക്കിന് 3 പോസിബിലിറ്റി ഇല്ലേ?
Yes, sunny,
ആ
overcast
അപ്പോ
and rain.
എച്ച് ഓഫ് എസ് സണ്ണി കണ്ടുപിടിക്കും. എച്ച് ഓഫ് എസ് മൈൽഡോ എന്തായിരുന്നു?
Sunny, overcast and rain.
ഓവർകാസ്റ്റ് ആൻഡ് എച്ച് ഓഫ് എസ്
Rain.
റെയിൻ. ഓക്കെ, ഈ മൂന്നും കണ്ടുപിടിക്കും. Similar to this.
Then
Then?
first we have to find sunny yes ആയ days നോക്കുക.
Ah.
Sunny no ആയ days നോക്കിയിട്ട് we have to calculate the entropy.
Yes. Then sunny given outlook കണ്ടുപിടിക്കാനായിട്ട്, sorry, information gain of outlook കണ്ടുപിടിക്കാനായിട്ട് we can consider the same what?
This 0.94. Then and we have to take the
0.904.
entropy of all the three cases.
3 cases into
Multiply with the
cardinality.
Ah.
Okay. So likewise, we will calculate the information gain of each one. And we can actually have a good illustration of this. I will show you. So first, നമ്മൾ ഔട്ട്ലുക്കിനെ ബേസ് ചെയ്ത് എന്ത് ചെയ്തു? ഹ്യൂമിഡിറ്റി, ഓവർകാസ്റ്റ് ഇത് സെലക്ട് ചെയ്തു. ഓക്കെ, സോ യു ക്യാൻ ഗെറ്റ് എ ഗുഡ് എക്സാമ്പിൾ ഓവർ ഹിയർ. സി സ്ലൈഡിൽ ക്ലിക്ക് ചെയ്താൽ മതിയേ. യു ക്യാൻ ഗോ ടു എ വെബ് പേജ്. See here, you can see one example of see ഇത് കാണാൻ പറ്റുന്നുണ്ടോ? Is it visible?
yes.
Okay. So here we are deciding whether it is a car or not. And for that, we have decision parameters, color, type, doors, tires. Okay. So the color can be red, blue, or green. The type can be XUV, minivan, car. Okay. Okay. And sorry, type classification, whether it will get the accident or not. Okay. Doors ഉണ്ട് and tires ഉണ്ട്. Okay, അല്ലേ? So some of the vehicles are prone to accidents and others are safe. Right? So accident ഉണ്ടാവുന്ന 1, 2, 3, 4, 5 cases and accident ഇല്ലാത്ത 1, 2, 3, 4, 5, 6, 7, 8, 9 cases. Right? So which parameter is actually indicating more into accidents? Okay. For that, we have to find out what the entropy for each of them, right? So we calculate entropy for each of them and we decided that, see, if you consider blue color വെച്ച് നോക്കിക്കഴിഞ്ഞാൽ അത് റെഡ് ആകുമ്പോൾ 2 പോസിറ്റീവും 2 നെഗറ്റീവും. ഇവിടെ 1 പോസിറ്റീവും 3 നെഗറ്റീവും. ഇവിടെ 2 പോസിറ്റീവും 4 നെഗറ്റീവും. 4 negatives are there, right? And if you split based on doors, it can be 2 or 4, right? So 2 എടുക്കുമ്പോൾ ഇവിടെ 4 positives, 3 negatives. Here it is 1 positive and 5 negatives. And based on type, it can be car, minivan, or SUV. Car which it can be what? 2 positives, 3 negatives. See, minivan edukumbo, these are all negatives. And on SUV, it is 2 positive and more negatives. And based on tires also, we can consider this 3 positives and 3 negatives, 2 positives and 6 negatives. So on calculating the information gain of all these things, what will happen? We will decide on a particular target. So among the attribute, color, type, doors and tires, the type with gain equal to 0.2. So we will consider this type because from this itself you can see that if it is minivan, definitely we are saying that there is no accident, right? So a kind of certainty is there, right? Are you getting that point? If you split based on type, and if it is a minivan, you can immediately decide there is no accident, no chance of accident. Are you getting it?
Yes, sir.
So this type is actually having what? More information.
Information gain,
Okay. So
less
we will,
entropy.
yeah. So we will split the data like this. Okay. Then again, what we can do is the type is now neglected, right? So from this, for this subset, again, I can choose what? Color, tires, right? And doors. For this subset, I can consider color, tires and doors, right? So there are white tires, black tires. There are, but all these things are what? Car. And these cars are actually having how many doors? For all these cars, I think all of them are actually car or minivan, right? For car and minivan, mostly, no, there are different number of doors. So it could be different. So we can consider doors or tires. Tires are different, doors are different, and color is also different, right? So we will actually recursively calculate the same thing. The probability, the entropies of tire, the entropies of door, and the entropy of color again at this point. Then based on which is having more entropy, we will split that
So,
here. Yeah.
we found that that information gain for one particular feature is more,
Fine.
or the entropy is less. We
Yes.
fixed that as one branch, right?
Yes.
Then the next step is you are choosing the other features.
Yeah, that is, we have to repeat the same procedure for this subset. This is not needed because this is only having one category, right?
Yes.
So there's no mix of classes. But for this and this, we have to repeat the same procedure. And you can neglect the type feature then.
Okay. Then again, you are trying to find the feature which is having
Among the three
maximum
features,
information gain.
among the three, which is having more information gain.
Okay.
And we will do that for this and this. Okay. So this is how it works. See, we are actually looking the outlook. If it is sunny, among the other features, which one is having more information gain? The humidity is having more information gain, right? Then based on humidity, we again split high and normal. But and while doing that, See, all the data came into no and all the data came into S for high and normal. So there is no need of further split here, right? And here also based on wind, the wind is strong, we are directly going to know. The wind is weak, we are directly going to S. Then there is no further split over here. If there are mix of S and No's on strong, we need to go for what? The next feature too. Is that clear?
I think we have to
Yeah,
spend
I
some
will.
time later, I think.
Yeah, we
Maybe
can
because
actually, I can actually give a complete solved out problem for you. You can actually go through it, then you will understand. Okay.
in the Sunny case, okay,
Yeah.
for Outlook was having more information gain.
Yeah.
And then for Sunny, again, we have other parameters, right? Because we have temperature, we have humidity, wind, those parameters were there.
Yeah.
For
There are
Sunny also, right?
no, Sunny is a value for Outlook.
Yes, but you are trying to connect it to humidity. That is why I'm asking. So rain to wind and Sunny
No.
to humidity. Why?
What is happening is, see, after splitting Outlook with Sunny, we will choose the data, okay? We will choose the data, what? Outlook Sunny ആകുന്ന ഈ data, ഈ data, ഈ data, ഈ data, ഈ data, ഈ data. ഇത്രയും data എടുക്കും. Right? And among that, this is what? Yes. This is what? Yes. This is negative. This is negative and this is negative, right? So we got
Yes.
a subset. We got a subset of the available data. This is the subset. This line, right? So what is happening is, again, we can actually neglect what? We can actually neglect Outlook now. Now the data we are having is this, this, and this, right? So there are three features: temperature, humidity, and wind. Right? Among this, which one is more informative? See, you can observe that whenever this humidity is high, the decision is no, right?
Yes.
Whenever the humidity is normal, the decision is
yes.
yes, right?
Yes.
So among temperature, humidity, and wind,
The humidity
which is
seems to be
more information gain.
okay.
And from that, if you choose high, now we have only no on the left side. And if it is normal, it is high. So there is no further split is needed because the uncertainty is actually over. Is it clear?
Yes, sir.
Yeah. Now we can actually discuss with. So the algorithms are actually over. Now we can discuss about some of the evaluation parameters of classification models. So how can I evaluate the classification models? Okay. So the first thing is we have to consider a confusion matrix. What is that? A confusion matrix. And how can we calculate the confusion matrix? See, suppose we have 100 data points. Okay. And among that, the 90 data points are used for training. And the 10 data points are used for what? Testing purpose. Is that clear?
Yes.
Right? So we build a classifier, whether it is a name-based classifier or a decision tree or a KNN or SVM or logistic regression, whatever it is. These 10 samples are actually labeled as, okay, actually labeled as 6 negative samples. So 6 negative samples and as 4 positive samples. Is that fine? This is the actual labels. And on predicting with a classifier, on predicting with a classification model, what is happening is I predict this as positive, this as positive, this as positive, this as positive, and this also as positive. But I made mistakes at this point, this as negative, and finally these things are also negative. Is it clear?
Okay. Because of the error in the classification,
Because
you are
the
getting
predicting,
some mistakes.
yes, getting some mistakes. Okay. So how can I calculate the performance of my classifier? Okay. So what is the criteria for that? We will be having a confusion matrix. And this indicates the actual ones, and this indicates the predicted ones. Okay. Actual ones and predicted ones. And this is positive, this is negative, this is positive, and this is negative. So what does this column means? Actually, it is positive and predicted as what? Positive. What is that measure? That measure is called as true positive. What is that?
3.
True positive. And this is actually positive, but predicted as negative. So these are false negatives. Right? And what about this? They are actually negative, but predicted as what? It seems like positive. So they are false positives. Okay? And this is true negative. Any confusions? Gaurav? ബാക്കി എല്ലാവർക്കും കൺഫ്യൂഷൻ ഒന്നും ഇല്ലല്ലോ? Right? Now, think about how many of the positives are predicted as positive. എത്ര positives ആണ് പോസിറ്റീവ്
Three.
predict ചെയ്തേ?
3.
3. So true positive is 3. Clear?
Yes.
Then what is this? False negative. How many of the positives are predicted as negative? 1. How
1.
many of the negatives are predicted as positive?
2.
2.
2. How many of the negatives are predicted as negative?
3.
4. And this is what we are calling as a confusion matrix. Is that clear?
Yes, sir.
Clear? Right. Now, with this confusion matrix, we can actually calculate the measures like accuracy. What is that accuracy? Accuracy is not given here. Yeah, one measure is actually called as accuracy. Accuracy is nothing but true positive plus true negative divided by total predictions. So what is the accuracy of this particular model? What is the accuracy of this particular model? 35 plus 52 divided by Adding up all these things, we will get 100 predictions, right? So 35 plus 52 equal to 87 by 100. So we can say that our model is having 87% what?
Accuracy.
Accuracy. Is that clear
Yes.
for everyone? Accuracy. Okay. And there is something called precision. And precision is nothing but among the positives. Okay. Precision. Krityada. Okay. Among the positives, how many of them are actually positives? Among the positive, I have predicted how many of them are actually positive. So, in this example, how many of them are actually predicted as spam? How many of them are I predicted as spam?
43.
How many of them are I predicted?
35
Predicted
plus
as spam?
35 are predicted as spam.
35 plus 8,
Ah, yes.
right? 35 plus
Yes.
8. And among that, how many of them are positive? 35.
35.
That is actually called as precision. Okay? Precision. Right? And again,
Sir, that precision is also applicable to false, true,
no,
negative
we
also, no?
always look for positive classes.
Okay, okay.
Yeah. Accuracy is a generic measure, but precision is calculated for each class.
True, negative is also a true thing, no?
If you consider the ham as positive, you can do that. Here the spam is positive, spam detection. So which one is the positive class? Spam.
Spam.
And if it is a ham detection problem, then ham can be considered as what?
Positive.
Positives.
Okay.
Okay. And recall. Recall is nothing but what? Among the total positives, how many of them are actually predicted as positives? മൊത്തം എൻ്റെ കയ്യിൽ എത്ര പോസിറ്റീവ്സ് ഉണ്ടായിരുന്നു, എത്ര സ്പാമുകൾ ഉണ്ടായിരുന്നു?
40 spam.
40 സ്പാം.
34 plus 5.
അതിൽ എനിക്ക് എത്ര എണ്ണം സ്പാം ആയിട്ട് കിട്ടി?
35.
35. So 35 by 40. അതാണ് 87.5. Is that clear?
Okay.
So ഇത് രണ്ടും കൂടി
Precision ഒന്നുകൂടെ പറയാവോ സാറേ?
ഞാൻ പോസിറ്റീവായി പ്രെഡിക്റ്റ് ചെയ്തതിൽ എത്രണ്ണം കൃത്യമായി പോസിറ്റീവാണ്?
ഓക്കെ ഓക്കെ.
മറ്റേത് ശരിക്കും എത്ര പോസിറ്റീവ് ഉണ്ടായിരുന്നു, അതിൽ ഞാൻ എത്രണ്ണം കൃത്യമായി പോസിറ്റീവ് ആണെന്ന് പറഞ്ഞു.
ഓക്കെ
ഓക്കെ അല്ലേ? യെസ്. And this F1 and F2, sorry, the precision and recall is actually a kind of trade-off ആണ്. ഒന്ന് precision കൂട്ടാൻ കൂടുമ്പോൾ റീകോൾ കുറയും, റീകോൾ കുറയുമ്പോൾ precision കൂടും. അങ്ങനെ നമുക്ക് വരാറുണ്ട്. സോ അതിന് രണ്ടിൻ്റെയും കൂടെ ബാലൻസ് ചെയ്തിട്ടുള്ള മെഷറാണ് ഇത്. ഓക്കെ. 2 into F1 score, 2 into true positive by 2 into true positive plus false positive plus false negative. പിന്നെ നമുക്ക് വേറൊരു രീതിയിലും പറയും 2 into precision into recall divided by precision plus recall. ഇതാണ് ഇക്വേഷൻ കേട്ടോ. 2 into precision into recall by precision plus recall. Okay, that is what we are calling as F1 score. Okay, so precision recall രണ്ടും നോക്കുന്നതിനേക്കാൾ you can actually go with F1 score. And we always call this recall as sensitivity. Okay, a sensitivity or true positive rate എന്ന് പറയാറുണ്ട്, TPR. Precision നമ്മൾ പോസിറ്റീവ് predictive വാല്യൂ എന്ന് പറയാറുണ്ട്. ആൻഡ് ട്രൂ നെഗറ്റീവ് റേറ്റ് കൂടി ഉണ്ട്. All of the negative, how many were correctly identified? That is specificity, true negative rate. Okay. And this ROC AUC curve is again another measure which gives an idea about how much the model is good. Okay. So ROC curve, receiver operating character. Okay. Receiver operating character. And what is this receiver operating character means? It will plot a true positive rate and false positive rate. True positive rate ഉം false positive rate ഉം നമുക്ക് തരുന്നതാണ് എന്ത് ഈ ROC കർവ്. അപ്പോൾ ഇതിന്റെ ഒരു വർക്കിംഗ് ഞാൻ പറയാം എങ്ങനെയാന്ന് വെച്ച് കഴിഞ്ഞാല് yeah. Are you able to see this board?
Yes, sir.
See, suppose logistic regression നമ്മൾ എടുക്കുന്നു എന്ന് വിചാരിക്കും. Okay? We are considering logistic regression. And we have 6 observations, 1, 1, 1, 0, 0, 0. And the logistic regression is predicting the values 0.9, 0.7, 0.5, 0.4, 0.2, 0.1. Okay, right? Okay,
With two different classes and the probabilities.
and the probability is predicted by a classifier. Okay,
Okay. So the third value is
1, 0.5,
above 0.5, 0.55.
or it could be 0.6.
Okay.
Okay. So what I'm going to do is, see, the threshold we usually choose is what? 0.5, right?
Yes.
Yes. So here I'm choosing 0.5 as our threshold. 0.5 as our threshold. And among the given one, these are all positive, right? And these are all negative, right? These are all negative. And by taking the 0.5, what will happen? By taking the positive, what will happen? These observations will be properly given as positive, and this will be properly given as
Negative.
negative 2, right? Then what is this TPR? True positive rate and false positive rate.
One
TPR
ആണോ TPR?
TPR എത്രയായിരിക്കും? 1.
One ആണോ?
TPR will be 1
One.
and
The other one is 0.
false positive will be 0, right? But if I choose this as 0.1, what will happen? It will be positive. All these things will be negative, right? All these things will be negative. So what is true positive rate here?
True positive is 1.
Sir,
Yeah.
0.1, how this 0.7 will be negative?
Sorry. I just-
0.8 something like, right? If you are
No.
considering.
All these things will be positive.
Yes, and only last value will be negative, right?
Yeah, yes.
Okay.
So among the actual positive, how many of them are actually predicted as positive? True positive rate, right? What is
Three
true
are,
positive?
three are actually true positives.
See, I will write the equation for TPR. What is the equation for TPR?
True positive by
TP by TP plus
TP
Fn,
by
right?
Mm.
TP plus TP by TP plus
Fn.
Fn, right? And what about FPR? False positive rate.
So
FP
Fp
by
by Fp plus Tn.
FP by TP
FP
plus Tn. FP plus Tn, right? So among the total positives, what is that? Among the total positives,
total or true positive?
true positive
True positive is 3.
plus true positive
3.
is 3. And false negatives are also true, right?
Two. Basic.
False negatives. Yes.
Yes.
That is
That is 0 here. There is no false negatives here, right? True positive, positive predicted as positive is 3. Negative predicted as positive, actual
false
negatives.
positive ആണ്.
Ah.
False positive.
So negatives predicted as positive. Negatives predicted as positive.
False
Positive,
positive.
negative, positive, negative. Positives predicted as negative, what? Nothing. Positive predicted as negative, nothing. And negative predicted as positive, 2 and
2.
1,
Yes.
right? So what is the TP rate? TP will be TP by TP plus
3
Fn.
by
Hmm.
false negatives 0.
False negatives are 0.
So
So
3 by
3
3.
plus 0. What, right?
That is 1.
1. And here it is false positive
False
rate.
positives 2.
False positives are 2.
By 2 plus 1.
3. False positive plus true negative.
Yes.
Okay. So it will be around 0.666, right?
Yes.
Right? So for each threshold value, the true positive and true negative will change. If you consider 0.2, again, it will be PNN, right? The true positives and true negative will change, right?
Yes.
TPR and FER will change. If you consider 0.5, 3 again, TPP, PNN. If you consider 0.4, PPP, NNN. If you consider 0.5, PPP, NNN. If you consider 0.6, PPP, NNN. If you consider 0.7, what will happen? PP, NNN, right? The true positives will get decreased, right? Are you getting it?
Sir, my question is this threshold is always 0.5, right?
Yeah, the threshold is 0.5. But for formulating this ROC AUC curve, okay, we will consider different prediction probability. That different prediction probability is considered and we will plot what TPR and FPR here. So in the first case, what is the value we got? Sorry. We got a TPR of 1, right?
TPR of 1. Yes.
And FPR of 0, right?
Yes.
Similar to that, see, these points are actually threshold values. We consider this points as threshold values. So for all thresholds, okay, so whatever thresholds itself, we always get what? See, if you consider positive, 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 negative, 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 and you got prediction probability for 1 for all and for all 0. So whatever threshold you take, the true positive rate will be here, right? And the false positive will be 0 here, right? So this will be the point. Are you getting that? If the classifier is predicting all positive samples with a probability of 1 and all negative samples with a probability of 0. Okay. Then whatever threshold you take, this will be here, right? Because the TPR is 1 and FPR is 0. So you will get a curve like this, right? That means your AUC is 1. What is that? Your AUC is 1 and it is a perfect classifier. Because under this curve, the area is what? 1 is calculated. That is 1 unit into 1 unit. Right? And
We got that TPR as 1 and false FPR as 0 for the case of 0.5.
yeah, point case. But if you consider, see the predictions as the positive classes are 3 and the negative classes are n. And the prediction probabilities are 1, 1, 1, 0, 0, 0. If you consider the threshold as 0.5, it will be PPP, NNN, right?
Yes.
If it is even 0.1, it will be PPP, NNN, right?
Yes, because you are having this 1, 1, 1 and 0, 0, 0 as the
0.
probability.
Probabilities. That is a perfect classifier, right? For
Yes.
all threshold, we get an FPR as 0 and TPR as 1.
Yes.
So you will get a rectangle kind of curve here. That says what AUC is 1. So AUC is a probability a random positive in rank higher than a random negative by model. So AUC 1 ആവുന്നത്, it means a perfect classifier. And this particular 5, this is 0.5. Okay. That is AUC is 0.5. That is you are getting a curve like this. For all cases, for the first threshold, you are having 0 true positives and 0 negatives. 0 true negatives. The next is 0.2 true positive and 0.2 true negatives. 0.4 true positives and 0.2, 0.4 false positive rate. If you are getting like this for each probability, for each threshold, what will happen? We are not getting a proper result. That is a random guess. So all curve above this line, okay, all curve above this line is actually a good classifier, and this is a very random classifier. And going below the slide is actually our model is not at all learned about our data. We are getting almost all false predictions for this.
So do you mean that for the model that we choose, we have to find this TPR and FPR and we have to
Plot this. And on plotting this, the AUC, the area under a curve is 0.5 means the model is a random one. That is half of the line is covered. But these lines are actually covering the area 0.87, this blue line. The green line is covering 0.95, right? So comparing these two, which one is good?
green.
Green is good. So clear. So if you try with multiple classifiers and if you plot the ROC AUC curve, one classifier which is giving maximum AUC can be considered as what? The best classifier. Is that clear? Okay.
The problem lies in we don't have to think about the threshold, right? We just have to find TPR and FPR
Yes, that's it.
for all the models,
For
whether
all
it
the
is
models.
KNN or all.
Yeah.
We have the test, we trained the model, then we have the test data, and in the test data, we have to find this TPR and FPR.
Exactly. Yeah. And this will work only for classifiers which give a prediction probability. Okay.
There is a problem, sir.
Yeah.
Like suppose you take one set and then you will get one value for TPR and FPR.
Hmm.
Here we have 0 to 1 FPR and 0 to 1 TPR. Are you taking different
Thresholds.
like for logistic, I understood the threshold, but for the other cases, we cannot take the
Oh,
threshold, right?
yeah, for other problems also, support vector machine and other problems also will give because in support vector machine also we are finding a hyperplane, right? If we apply that hyperplane
Yes.
on a sigmoid function, what will happen? You will get a probability, right?
Yes, but the reason is, suppose like in the case of sigmoid function, we are putting that means one can adjust the threshold and then find the which one is better, right? I didn't understand how you are getting this different 0 to 1 TPR and FPR for the same set of data.
First, what we will do is we will simply predict the probabilities. For all test data, we will simply predict the probabilities. Okay. Then first, what we
Okay.
are doing is we will fix a threshold, and with that we will calculate the TPR and FPR. The threshold as 0, 0. Then 0.1, 0.2, 0.3. We will calculate what? Different
TPR and
TPRs and
FPR.
FPR. And that is actually plotted over there. Maybe you can see one illustration. Example of ROC calculation. So, no. See, this is the actual class. Okay. Can you see this? This is the actual class. These are the prediction probability. First, we will consider what? 0.6 as a threshold. Then we will consider 0.7 as a threshold. Then we will consider 0.8 as a threshold. At each time, you will calculate what? TPR and FPR. Is that clear?
Yes, sir.
Yes. Then this will be plotted like this. The first case, what is the TPR? It is 1. And sorry, TPR is 0.75 and FPR is 1, right? So the first one is FPR is 1 and TPR is 0.75. So what is the point? We can get a point like this. Okay, and that is for 0.6. So each point we will consider what? A threshold value. Then we will plot that. Then we are actually getting C, A, B, C, D, E. So these values are at different thresholds.